Hello everyone, I am Mohammad Ahmad Qureshi, working as an assistant professor in Civil Engineering Department at RNG Patel Institute of Technology, Bardoli. Till now, we had discussed seismic methods of analysis examples in design of reinforced concrete structure subject. So, we will commence our same sum from vertical distribution of base shear. So, we had discussed earlier how to calculate the base shear for the seven-story RC frame building for hospital located in Bhuj using seismic coefficient method. And in these examples, we had calculated design base shear as 4483 kilo Newton. In the previous lecture, we had calculated the design seismic base shear VB as 4483 kilo Newton. Now we will begin further with vertical distribution of base shear. So our next step number 5 will be vertical distribution of base shear. The design base shear VB that we had computed above shall be distributed along the height of the building as per the expression Qi equals to VB into Wi Hi square upon summation of I equals to 1 to n Wi Hi square. This equation is given in IS 1893 part 1 2002 page number 24 clause number 7.7.1. So this vertical distribution of base shear shall be calculated by this expression. Now, as we know that our Qi is design lateral force at floor I, that is I equals to 1 to n, and Wi, that is our seismic weight of floor I, that is I equals to 1 to n, and Hi is the height of floor in meter from base. Okay, now we will go for lateral load distribution with height. So as we obtain the value of VB as 4483 kilonewton, we will first distribute all the floors. So here floor level 7th, which is nothing but roof 6, 5, 4, 3, 2 and 1. Our 7-story building. Now Wi, that is seismic weight of floor I, which is in kilonewton. Then HI height of floor, it will be in meter. Then according to expression Wi Hi square and Wi Hi square upon summation of Wi Hi square, and last here your equation Qi equals to VB Wi Hi square upon summation of Wi Hi square, and lastly our shear Vi in kilo Newton. So for roof we had calculated the value of W as 4277.77. In the previous example, we had calculated both these value, floor as well as for each floor level. Then for sixth floor, we had calculated 5523.84. Similarly, for all floor 5523.84. Here also same 5523.84, and for second as well as for first floor it will be same. Now height, as the story height is given in the data 3.5 meter, so for second it will be double 7, then 10.5, then 14, then 17.5, then 21, and for entire building it will be 24.5. So now we have to multiply both these values, that is 4277.77 into 24.5. So you will get 2567731.44. Similarly, we have to multiply 5523 into 21. So we will get 2436013.44. Then same process 1691676.0 and 1082672.64, 609003.36, 270,668.16, and 67667.04. So we will write here summation of Wi Hi square equals to 8725432.08. So now Wi Hi square means here this value we had calculated in this column. So 2567731.44 divided by this value summation of Wi Hi square. So you will get 0.2943. Similarly, we have to repeat this step for each floor level. So you will get for sixth floor 0.2792, 0.1938, 0.1241, 0.0698, 0.031, and for last, that is for first floor 0.0077. Now we know that Qi equals to VB into Wi Hi square upon summation of Wi hi square. So we have to multiply this column with Vb to achieve this expression. So we had calculated earlier Vb as 4483 kilo Newton. So after inputting all the values, you will get 1319.35, 1251.65, 868.80, 556.34, 312.91, 138.97, and 34.52. Now your summation of Qi will be exactly equals to Vb. So after summation of all the values of Qi, you will get 4483 kilo Newton, which is exactly equals to the value of Vb. Now for shear force, we will write this value here, 1319.35. Then by cumulative, we have to add this value with 1251.65. So you will get 2571.00. Similarly, we have to add 868 with 2571. So we will get 3439.80. Similarly, after adding this value, we will get 3996.14, 4309.05, 448.02, and lastly 4483.00. So now we have to plot the lateral load diagram for the given data, and for lateral load diagram we have to input all the values that is related to Qi, and for shear diagram we have to input all the values that are related to Vi. So you will get the lateral load diagram as this. All these values are calculated in the previous step, and for shear diagram from first to terrace floor we have to input all the values that we had calculated in the previous slide. So by this way we have to find the base shear using seismic coefficient method, and we have to draw the distribution of shear at each floor level by indicating all the values that we had obtained in lateral load distribution with height table. Now we will go for another example. In this example, it is given that we have to calculate the horizontal shear force acting at each slab level by equivalent lateral force method. As we had discussed earlier, that the seismic coefficient method is also known as equivalent lateral force method. Means our step will remain same that we had done in seismic coefficient method. Seismic coefficient method is also known as equivalent lateral force method and static coefficient method. Both names are for seismic coefficient method only. Now, a five-storied building. Here it is given that it is five-storied building of size 30 meter into 30 meter, and it is located in Bhuj and resting on hard soil. So it is located in Bhuj. Hence, the zone factor for Bhuj we had discussed in the previous example that it lies in zone 5 and therefore the value of zone factor will be 0.36, and it is resting on hard soil. So in parameter SA by G, this hard soil parameter will be beneficial for us, as SA by G factor depends on the type of soil and the fundamental natural period TA, and the weight of flows and height of the flows are 2000 kilonewton, 2500 kilonewton, 2500, 2500 and 2100 kilonewton, and height are 4.5 meter, 3.5 meter, 3.5 meter, 3.5 meter and 3.5 meter respectively. From slab number 1 from bottom, assuming the building as SMR, office building. Hence, for office building, we have the importance factor as 1. Now we will solve the example. As it is given that we have to calculate the horizontal shear force by equivalent lateral force method. And as we know that equivalent lateral force method is nothing but seismic coefficient method. So now we will write the given data. So W1 equals to 2000 kilonewton, W2 equals to 2500 kilonewton, W3 equals to 2500 kilonewton, W4 equals to same 2500 kilonewton, W5 equals to 2100 kilonewton. So from here we will get the total weight of the building as 11600 kilonewton. Now it is also given that the height 4.5 meter, H2 3.5 meter, H3 same 3.5 meter, H4 same 3.5 meter, and H5 is also same as 3.5 meter. So here we will get the total height of the building as 18.5 meter, and the dimension of the building is given as 30 meter into 30 meter. So here we get the value of H, height of the building, as 18.5 meter. So this value will be helpful for calculating the fundamental natural period, that is TA equals to 0.09 into H, where H is height of the building. So here we will input the value of H 18.5 in that equation, and the base dimension is given as 30 meters. So here we get the value of small d. So now we will calculate the fundamental natural period. So our first step will be fundamental natural period, that is TA. So here consider RC frame building with infill brick panels. So from IS code 1893 part 1 2002, page number 24, clause 7.6.1, we will get the equation for TA as 0.09 into H upon root D. Therefore, TA equals to 0.09 into H we had obtained earlier as 18.5 and D as 30. So here H will be your 18.5 upon under root of 30. So you will get the value of TA as 0.304 seconds. Now we will go for design seismic base shear VB. As we know that VB equals to AH into W, and we obtain the value of W as 11600 kilo Newton. So here the value of W, that is 1160 kilo Newton, and we know that AH is nothing but horizontal seismic acceleration coefficient given by Z by 2 I by R SA by G. Since value of Z, that is zone factor, and in the given data it is given that the building is located in Bhuj, hence Z factor for Bhuj will be zone phi, and for zone phi the value of Z is 0.36, and then importance factor, that is capital I. Importance factor, it is given that building is office building. So here the importance factor I for office building, it is given in IS code as 1, and response reduction factor considering SMRF, the value of R will be equals to 5, and SA by G will depends on type of soil and the fundamental natural period TA. As the type of the soil in the given data is hard soil, hence for hard soil and TA equals to 0.304 second, you will get the value of SA by G as 2.50. So now putting all the values in equation AH equals to 0.36 into 1 into 2.50 divided by 2 into 5. So you will get the value of AH, that is horizontal seismic coefficient AH equals to 0.09. Hence, your design seismic base shear, that is VB, will be equals to AH into W, and value of AH we obtained as 0.09 into W is 11600. So you will get the VB as 1044 kilo Newton. Now, this base shear computed shall be distributed along the height of the building as per IS 1893 Part 1 2002, page number 24, clause 7.7. So we will go for vertical distribution of base shear, that is VB. So here our VB is 1044 kilo Newton. Now we have to distribute this 1044 along the height of the building as per IS code. Hence, we will go for floor level WI kilonewton, HI meter, WI HI square, WI HI square upon summation of WI HI square, and using the expression Qi equals to VB into WI HI square upon summation of WI HI square in kilonewton, and lastly the shear force VI kilonewton. So in the given data, it is given that the building is 5-story. So here we will write 5, 4, 3, 2, and 1. And the value of Wi for each floor level is given in the data. So we will write that value 2500 for fourth, similarly 2500 for third, for second also 2500, and last, that is for first floor, is 2000, and the building height is given as 4.5, 8, 11.5, 15, and 18.5. So we have to multiply this value with the square of this value. So we will get 718, 725, 562, 500, 330, 625, 160, 000, 40, 500. So we will write here summation of Wi HI square equals to 1812350. And here Wi HI square means this value divided by this value will be equals to 0.3966, 0.3104. You have to put the value of Wi HI square for particular floor, and you have to divide this value with 1812350. So you will get the corresponding value 0.1824, 0.0883, 0.0223, and Qi is nothing but VB into this column Wi HI square upon summation of Wi HI square. So value of VB that we obtained earlier as 1044, value of VB is 1044. So we have to multiply this value, all these columns, with 1044. So you will get 414.05, 324.06, 190.43, 92.18, 23.28. So summation of Qi will be equals to 1044 kilonewton, which is equals to the base shear. Now we will write this value over here 414.05, and now we have to take the cumulative value. So 401, sorry, 414.05 plus 324.06, you will get 738.11. Now 738.11 plus 190.43, so you will get 928.54. 928.54 plus 92.18, so you will get 1020.72, and 1020.72 plus 23.28 will be equals to 1044.00, which is equals to the VB. So after getting all these values, you have to draw the lateral load diagram and the shear diagram. All these values has been calculated in our previous step. You have to just indicate all these values in the respective diagram. So this is the end of seismic coefficient method. We will calculate examples related to the other method in the next lecture. So thank you.